Close your eyes for a second. Imagine a beep getting quieter. Quieter until you're not sure if it's there. That razor-thin moment between I hear it and I don't. That's where psychophysics lives. Psychophysics is the toolkit experimental psychologists use to turn sensations into numbers. Not guesses. Not vibes. Numbers. How bright is barely visible? How much louder before you notice? Can you tell two tastes apart? We can measure that. Two ideas unlock everything. Absolute threshold. The smallest signal you can detect usually define where you say yes about half the time. Difference threshold, the JND, the smallest change you can reliably notice from a reference. Here's a mind bender. Your ability to notice change depends on where you start. If a room is already bright, the light has to increase more for you to notice. That's the heart of Weber's law. The JND scales with the baseline. Fechner took it further. Your sense of how strong it feels grows roughly with the log of the physical intensity. They're not perfect laws, but they're powerful shortcuts. How do we measure this in real experiments? Classic methods, super fast. Method of limits. Sweep intensity up or down until now I detect it, then average the flip points. Quick, but people anticipate. Method of constant stimuli. Show random intensities and record yes-no. Slower, but it gives a beautiful curve of performance versus intensity. Method of adjustment. Let the person turn a knob to just detectable. Lightning fast, but more subjective. Modern upgrades for clean data. Staircases. After a yes, go down. After a no, go up. The levels hover near your threshold. Efficient and reliable. Forced choice, like 2A fake. Which interval had the signal, first or second? This reduces bias because you must choose. Speaking of bias, here's the trap most people miss. Two people can have the same sensory ability, but totally different decision habits. One says yes a lot, more hits but more false alarms. One is cautious. Fewer false alarms, more misses. Signal detection theory separates these. D prime, D equals true sensitivity. Criterion equals how liberal or conservative the decision is. Change the rewards, the stress, or the instructions, and the criterion moves, even if your actual sensitivity doesn't. That's why pros love 2A FOC or UROC curves and ratings to estimate D. Let's make this real with two quick experiments you could actually run. Experiment 1. Visual contrast threshold. Fast, bias resistant. Show a faint stripe pattern in either the first or second. Ask, which interval had it -1 or 2? Use a staircase to nudge contrast up after mistakes, down after correct answers. After a few reversals, you'll have a threshold near 75% correct. That's your number. Experiment 2. Auditory toned detection with SDT. Learn sensitivity versus bias. Present very soft tones at several levels. Ask yes, no, plus a confidence rating. Fit a curve to find the 50% detection point. Use confidence to plot an ROC curve and compute D, your pure sensitivity, independent of trigger-happy responses. Probe moves that separate great data from junk. Randomize order to kill anticipation. Collect plenty of trials right around the decision boundary. That's where the curve lives. Include easy, catch trials to estimate lapses or attention drops. Calibrate stimuli, screen brightness, sound levels, and keep the room consistent. Define the threshold up front, 50% detection, 75% correct. Stick to it. What can go wrong? My threshold improved, so my perception is better. Maybe, or your criterion just shifted. Check D. Weber's law failed at very low intensities. It does. Laws are approximations. Report where they hold. Adjustment says X, constant stimuli says Y. Adjustment is fast, but criterion prone. Anchor with forced choice or constant stimuli. Why this matters outside the lab. Designing alerts people actually hear without being annoying. Screen brightness that's readable without eye strain. Tuning hearing aids and diagnostics. Evaluating VR, AR, comfort. Haptics, taste and fragrance, R&D. Anywhere humans sense and decide. Here's your takeaway. Psychophysics makes the invisible visible. It turns "I think it's brighter" into "here's the threshold, the slope, and the sensitivity," with confidence intervals. If you work with human perception, even as a creator, this is the difference between guessing and knowing.